For the past few years, the story of AI has seemed pretty simple, right? Bigger is better. We've all heard it. Just scale up our models, feed them more and more data, and boom, we'll eventually hit true intelligence. But what if that's not the whole story? What if the very foundation of the AI we see everywhere today is actually a dead end when it comes to understanding the real world? Okay, so let's really get into this. On one side, you've got generative AI. That's the tech behind all those incredible images and videos you see online. How does it work? Well, it tries to predict every single pixel in a sequence. But on the other side, there's this totally new approach called predictive AI. And this thing, it couldn't care less about the tiny details. It's all about the big picture, the deep underlying meaning of what's actually happening. And this is not some fringe idea, okay? This comes straight from Yann LeCun. Yeah, the Yann LeCun, one of the godfathers of deep learning. And his argument is pretty profound when you think about it. He's saying reality isn't just a long sequence of words or pixels for an AI to guess. No, it's a system that's governed by rules, by physics. And to truly get that, an AI needs to learn to think in a completely different way. So let's dive into this idea of the generative lie. We're going to break down exactly why trying to predict every single little detail might actually be a massive, inefficient distraction, one that's holding AI back from truly understanding our world. And the solution that LeCun's team over at Meta just put out there? It's called VL-JEPA. Now, I know the name is a mouthful, but the concept behind it is pretty revolutionary. See, this AI isn't designed to make flashy videos. Its whole purpose is to watch a video and fundamentally understand what's going on, on a deep conceptual level. Now, to really grasp why VL-JEPA is such a breakthrough, we first have to wrap our heads around the core problem it's solving. And that problem is the massive, just incredible inefficiency that's baked right into the generative models we use today. And this tree analogy, it explains the issue perfectly. Just imagine an AI watching a tree on a windy day. A generative model, something like Sora, would waste a ton of energy trying to predict the exact flutter of every single leaf. But all that detail, it's basically just random noise. Now, a predictive model like JEPA, it just ignores the leaves and comes to a simple conclusion. It's windy. See? It gets the essence, not the static. And that's really the crucial point here. It's this huge philosophical shift. Instead of wasting all that computing power trying to create a perfect pixel-for-pixel copy of reality, this new kind of AI focuses all of its energy on just one thing, predicting the abstract meaning of what's gonna happen next. So the big question is, how does it actually do this? How can an AI learn to predict meaning without getting totally lost in all the pixels? Well, the architecture is incredibly clever. Let's walk through how it works. It's basically a 4-step process. So, first, the AI watches a scene from a video. Second, and this is key, it doesn't save the pixels. Instead, it compresses the whole scene into a super compact mathematical representation of its core meaning. They call that an embedding. Third, it uses that meaning to predict the next likely meaning, and then only at the very end, if a person actually asks a question, does it bother to translate that abstract thought into words. Now, this concept of the silent semantic state is where things get really fascinating. This is the magic trick. The AI figures out the answer, right? It predicts what's coming next, but it holds that answer as a pure concept, just a set of coordinates in its internal map of ideas. It actually thinks before it speaks. This is totally different from a large language model that just spits out an answer one word at a time. And this silent approach has a massive, game-changing practical benefit. By separating the act of thinking from the act of generating words, the model becomes unbelievably efficient. And the key takeaway here is that this efficiency, it's not just some nice little bonus. It's the gateway to making AI truly useful out there in the real world. This amazing efficiency comes from a feature they call selective decoding. Because the AI is only tracking abstract meaning, it can basically just ask itself, hey, has anything important changed here? So if a camera is just staring at a blank wall, the meaning is sable, right? The AI essentially goes to sleep. It does nothing. But the second a car drives by or a person walks into the room, the meaning changes and the AI wakes up to process what just happened. And the result of all this? The official paper shows this method is almost 3 times more efficient. Now, this isn't some small incremental improvement. This is the kind of massive leap that makes always-on AI possible on devices with tiny batteries. Think smart glasses or home robots. It's the difference between your glasses lasting maybe 2 hours versus lasting all day long. That's a game changer. Okay, so the theory is great, it's super efficient, but does it actually perform better? Let's get to the good stuff, the benchmark data, and see how this new architecture really stacks up against the current industry heavyweights. Well, across a whole bunch of benchmarks, all designed to test how well an AI perceives what's happening in a video, VL-JEPA consistently comes out on top. It just has a much better grasp of real-world actions and events than the older models do. Simple as that. And what's truly impressive, what really blows my mind, is that it gets these better results while being way, way smaller. We're talking just 1.6 billion parameters. That's roughly half the size of some of its generative competitors that it beats. It's absolutely punching above its weight, all because it doesn't waste energy on stuff that doesn't matter. But honestly, the coolest test is what they call intuitive physics. In these tests, an AI has to spot when something physically impossible happens, like an object suddenly teleporting across a room. Generative models, they often fail this because if they can't see an object, they basically forget it exists. But JEPA models, they nail it because they understand object permanence. They know that a ball that rolls behind a box is still there. They aren't just describing a scene, they're actually simulating a world. All of this points to a much, much bigger vision for what AI can be. We're starting to move beyond these disembodied chatbots that just live on servers, and we're moving toward intelligent agents that can actually perceive, understand, and eventually interact with the physical world. It's the difference between an AI that can describe a recipe and an AI and a robot that can actually cook the meal. It's all about grounding intelligence in reality. So we have to be nuanced about this, right? It's about the right tool for the job. If your task is all about manipulating language, say writing code or a poem, a large language model like GPT-4 is still going to be your best bet. But if you want an AI to understand and navigate the physical world, for a robot to catch a ball, or for smart glasses to guide you through a new city, then this predictive architecture is just worlds better. Here's a really powerful way to think about all this. For the last few years, what we've really been building is the language center of the AI brain. Large language models, they're the voice. They're brilliant at communication and using symbols. They can talk about the world. But with JEPA, we're now building the other parts, the sensory and motor cortex. We are giving AI the eyes to see the world and eventually the hands to actually do things in it. This is the part of the brain that doesn't just talk about the world, it experiences it. And you absolutely need both to have a truly complete intelligence. This really is a key step on the big roadmap to what LeCun calls advanced machine intelligence. It's all built on this core belief that you can't create true AI from text alone. It has to be grounded in a deep understanding of the physical world. VL-JEPA is the first major proof that this world model idea really works. And by open sourcing the code, Meta is basically inviting the entire research community to come and help build this future together. So this all leaves us with a really fundamental question. As we push forward, what do we need more? Do we need an AI that's a better writer, one that can produce even more eloquent language? Or do we need an AI that's a better thinker, one with a deeper and more grounded understanding of our reality? The answer we choose will almost certainly shape the next decade of technology.